For number 3 on the same worksheet, vertical motion practice 3, it's asking or it's saying that Colin takes 13 seconds to solve a Rubik's Cube. He wants to solve a Rubik's Cube as he jumps out of an airplane before he enables his parachute. The airplane is traveling at 10,000 feet and Colin has to open his parachute at 2,000 feet. And we want to know if he has enough time to solve this Rubik's Cube. So again, we always start off with the same equation. Okay. And we have to figure out what we need, what variables we know, and what variables we need to find. So in this problem, it says that the airplane is traveling at 10,000 feet. So that's the starting height of Colin. If he's jumping out of the airplane and it's at 10,000 feet traveling, well, that's where he's going to jump out. That's where he's starting at, 10,000 feet above the ground. He wants to open his parachute at 2,000 feet above the ground. So the ending height, the height that this Rubik's Cube he wants solved by, is 2,000 feet. Now, I do not have a velocity, and the reason I don't have a velocity is because he is just jumping out of an airplane. It did not tell us at what rate. It sounds like he is just going right off. So the velocity is 0. If they don't give it to me, it says he's going out of an airplane, the velocity is 0. We don't know the time. That's what we need to figure out. We need to know if there's going to be enough time for him to do this Rubik's Cube between jumping out of the plane and opening his parachute. He needs at least 13 seconds. So if he has at least 13 seconds, he'll have enough time. So let's plug in what we know. We have 2,000 equals negative 16 t squared plus 0 times t plus 10,000. Now there's two ways to solve this problem. One way, you can make it equal 0 by subtracting 2,000 on each side, and then use the quadratic formula. In my opinion, an easier way is, since I know 0 times anything is 0, I don't need that middle term on the right side. So I can have 2,000 equals negative 16 t squared plus 10,000. Since I only have one variable, I can isolate that using inverse operations. So to move the positive or addition of 10,000, I could subtract it to get negative 8,000 equals negative 16 t squared. The inverse of multiplying by negative 16 is dividing. So if I go and I divide by that, I end up with 500 is equal to t squared. And the inverse of squaring is square rooting. You end up with two answers, a positive and a negative, 22.36. It's approximately equal to our t value. Now we do know there's two answers when you square root, but when you want to apply it to a real-life problem, you cannot have a negative amount of time. So the answer we're looking for is the positive answer. So it will take 22.36 seconds from the time that Colin jumps out of the plane till the time he has to open his parachute. Since in the problem it says it only takes him 13 seconds to solve a Rubik's Cube, and he's going to have 22.36 seconds to answer the question of will he have enough time, the answer is yes. He will have enough time. And he will have enough time again. If he has 22 seconds, but he only takes him 13, he's going to have 9 seconds left over. The last problem is going to make us refer back to number 2. So number 4 is asking, what is the maximum height of the rocket from problem 2? So if I go back up to problem 2, problem 2 says Terry launches a rocket from the ground at a rate of 115 feet per second. So velocity was 115. From the ground means my starting height was 0. Now, question might come up. Well, in number 2, we used h was 12. Do I use h is 12 for number 4? And the answer is no. Number 2 is specifically asking for a time at 12 feet. Number 4 is not specifically asking for a height at 12 feet. It wants to know the maximum height, and that height we do not know. We also don't have a time. We don't know how long it's going to take to get to that maximum height. And those are both things that we need to find to answer number 4. So to write the equation for number 4, it's not exactly the same as number 2 for the reasons I just said. You're not ending at 12 feet anymore. You want to know what the maximum height is. So I'd have negative 16t squared plus 115t plus 0. Now you really don't need to have 0 at the end if you don't want to. When it says maximum height, that tells you it's a separate type of problem. And in order to find the time at the maximum height, we use the formula of the opposite of b over 2a. Well, in this case, a is negative 16, b is 115. So I'd have the opposite of 115, which is negative 115, over 2 times the a value of negative 16. Well, if I simplify the bottom, I have negative 32 on the bottom. And when I divide those, I get approximately 3.59 seconds. In order to get the height now, that tells me how long it takes to get to the maximum height. So it'll take 3.59 seconds to reach the maximum height. We don't know what the actual height is yet. I have to take this t and plug it in for t in my original. So I'd have negative 16 times 3.59 squared plus 115 times 3.59. Again, it's not necessary to hit plus 0 at the end. So I will type this into my calculator, just as I hope you are doing the same thing. And when I do that, I end up with h being approximately equal to 206.64 feet. So to answer the question, again, I just took my t and I plugged it in for t in parentheses in my original equation up here. So the maximum height is about 206.64 feet. I really hope that this helped you. I am available via Remind until about 8 o'clock tonight if you have additional questions. I will be in before school. The earlier you come, the better. I'm here at 7 a.m. We do have a quiz tomorrow. Hopefully this helped.